With over 1.7 million people residing in just 94 square kilometers, Kuala Lumpur has one of the highest population densities globally. However, rapid urbanization is resulting in a significant challenge to livability in the region. Beyond connecting citizens and visitors in the Klang Valley region, Malaysia's Mass Rapid Transit Corporation, or MRTC, is helping transform Kuala Lumpur into a green city. Construction of its Klang Valley Mass Rapid Transit project will contribute to a rail-based public transport network within the capital city, as well as new sustainable park and ride facilities and public amenities.
KV MRT system is providing a major boost in the integration and efficiency of urban public transport.
The country's largest infrastructure project is already having a significant economic impact in Malaysia and within the region. As the first metro project in Asia Pacific to ensure greater collaboration and efficiency across teams with building information modelling, or BIM, methodologies, the SSP line is expected to be delivered on schedule and on budget. Taking advantage of digital technologies for its SSP line, MRTC is improving connectivity for local and regional businesses, expanding workforce skills, attracting international investment, and increasing property values across the Klang Valley region. Digital transformation is helping transform the lives of millions of Malaysians today in preparation for a better tomorrow.
Assalamualaikum, salam sejahtera, and a very good morning to all of you. It is great to be here today, and I am excited to share on how Mass Rapid Transit Corporation Sdn Bhd has embraced digital engineering technology in engineering design and construction for our MRT Sungai Buloh Serdang Putrajaya Line project. The MRT SSP line is the second MRT line after MRT SBK line. The entire alignment will span to 52.2 km, which consists of 13.5 underground tracks and 38.7 of elevated tracks. And it will serve a corridor of a population around 2 million people, stretching from Sungai Buloh to Putrajaya. The MRT SSP line will have 35 stations, which 24 are elevated and 11 are underground. The picture shown here is the SSP line rolling stock, which has been awarded to Hyundai Rotem from South Korea. This rolling stock will include 58 4-car driverless electric train, which can carry up to 1,200 passengers at one time. This is the architect impression of the MRT SSP line elevated station. The elevated station architecture was inspired by the concept of serambi at Rumah Kampung or Rumah Panjang. This concept provides open space, natural lightings, natural ventilation, and natural visual effects via play of lights and shadows. The SSP line will start from the existing Sungai Buloh depot and will pass to the residential area in the northwest of Klang Valley. This will include residential areas such as Damansara Damai, Kepong, Jinjang, and Jalan Ipoh. Once it's reached the city center, the train will start going underground from Sentul West, going to Titi Wangsa, Kampung Baru, Ampang Park, KSCC, Toraza Exchange, Tan Saulin, and back to the elevated alignment at Desa Water Park near Jalan Kuchai Lama. The line will continue toward southeast of Klang Valley, which will pass through the residential such as Kuchai Lama, Sedang Raya, UPM, Sri Kembangan, our second depot at Sedang before Equine Park, 16 Sierra, Cyberjaya, before terminating at Putrajaya Central. The project has reached 40% progress of the underground construction and 30% of the elevated system. The operation of the SSP line will be in two phases of this project. Phase 1, the Sungai Buloh station from Kampung Batu station will begin operation in second quarter of 2021, while the rest of the Kampung Batu station to the Putrajaya Central will be operated under phase 2 in the second quarter of 2022. These are some of the photographs of our construction progress. You can see we are currently constructing MRT station near to KLCC, Chan Sao Lin, and our tunnel boring mission launch site at Bandar Malaysia North, and some of the elevated station at Damansara Damai, Damansara East, and Metro Prima area. Now, I would like to share some of the project challenges that we have in this project. The MRT SSP line consists of 500 multidisciplinary professionals like architects, engineers, planners, geologists, and controllers. And these people are the heart of MRT SSP line project. And we are responsible to deliver the SSP line project within budget and within time to the government of Malaysia. Our work involved in the design and the construction of the SSP line underground, elevated guideways, depot, tunnels, and station, as well as the electrical and mechanical system required for a fully functional railway system. It is very important for us to make the information available across the project accurately, up to date, and no misinterpretation between the stakeholders. We need to ensure the design information, as-built information, and as-built validation are being managed and are being kept within the project, as the MRT structures and station will have a long lifespan, which is 120 years. Next is the technical complexity of the design. This illustration shows on how complex it is to design and construct the MRT station. This involves cross-functional and multidisciplinary fields within a tight schedule. The engineering design information need to be organized in a systematic and structured way so that it is easy to retrieve. The attribute also need to be updated correctly according to project classification requirement. To overcome these challenges, MRT Corp has embarked on digital transformation program for engineering design and construction for this project. The main objective of our digital engineering program is to improve the SSP line project productivity by 35%. In order for us to achieve this, we are pushing 6 digital engineering initiatives into our project. We are mandating the use of BIM Level 2 framework for our underground and system work package contractor to carry out design process in the Common Data Environment or CDE following BS 1192 standard. We developed GIS web portal to host all design and engineering information, utilities, as-built and construction models. We are also utilize reality models using drone for site progress and monitoring. We are also using 3D laser scanning and BIM model validation and as-built scanning. Together with our contractor, we are pushing the construction management going paperless, mainly for the inspection, dashboard reporting, and progress update using a smart apps. Next, I would like to showcase some of our work on how we have applied digital engineering in the design and the construction of the MRT SSP line project. For this demo, we have picked MRT Titiwangsa Station, which is one of our favorite stations. The MRT station located beside Jalan Tun Razak near to existing LRT Titiwangsa Station and KL Monorail Titiwangsa Station. The MRT station is intended to be interchange station that will be integrated seamlessly with Ampang Line and KL Monorail Line. Now, let's have a look at the GIS implementation in the MRT SSP line project. For this project, our geospatial portal is using ArcGIS Enterprise 10.5. We are currently compiling all engineering drawing, spatial information, document and records into a centralized mapping viewer. The video shows a collection of soil investigation boreholes that we have converted from AGS4 format from our geotechnical team. The AGS4 is a text-based format and it contains detailed information about soil profile. In order for us to bring this data into a GIS portal, a special conversion tool has been developed. Now, our geotechnical engineer have the ability to see the borehole report together with the visual representation. We also create a widget to highlight the depths and the soil type of each borehole. It will provide a graphical representation of the soil depth. Here is the video of few boreholes in customized widget viewer that highlight the soil profile and the soil depth in the ArcGIS portal. In addition to the compilation and presentation of the geotechnical data, we are also created an API to interface with leading geosystem and tunneling software. The purpose of this API is to map the tunnel progress every day in the GIS portal. So you can see here, the information like tunnel position and ring progress are being tracked daily in the GIS system. For this project, MRT Corp has moved from on-premise server to cloud-based server implementation, which provide better reliability and availability of all our project data. We are adopting Microsoft Azure Cloud for both GIS production and development servers. These servers are fully interfaced with KVMRT CDE, and we are also replicating both server in cloud and on-premise to backup and to protect our project data. We are also proud to share that we are the first project in Asia region to have ArcGIS Server Enterprise on full cloud configuration implementation. Next, I'm going to share things that keep us busy every day, using GIS data with BIM and Reality Model for this project. The SSP line is one of the first in Asia region and among very few in the world to implement BIM Level 2 for an infrastructure of project of this scale and complexity. This model demonstrates the station design complexity in 3D, and it allows our engineer to visualize, to collaborate, and to analyze every aspect of engineering in virtual world for design and construction process. To help our engineer retrieving the Titiwangsa model quicker, faster, and intuitive, we have interfaced our GIS portal with project CDE infrastructure directly in the clouds. Engineers can retrieve this model directly using a viewer simplified interface pop-ups and attributes linked to the models using ArcGIS Pro. This is the 3D models that are being retrieved from ArcGIS Portal in 3D modeling software. We are also pushing the boundaries and setting up benchmarks in various aspects of project development. Among them is the use of reality modeling. Reality modeling is a combination of drone and imagery for reality mesh software. These outputs are being used by our engineers to review the current progress at site, conduct visual inspection, perform measurement, and review stockpile volume. What you see here is reality modeling of TT Wangsa Station and the detailed construction of the construction progress. We have a monthly program to capture reality modeling for all our underground sites. The scene layer output in Esri i3S format are being reviewed, compared, and fused with BIM model in ArcGIS Pro before we publish the unified model into 3D scene viewer. This video shows the monthly routine by our GIS engineer reviewing the content construction progress using BIM model and latest reality model in ArcGIS Pro. Once the 3D model ready, ArcGIS Pro will be able to fuse the model as one unified before publishing into Esri 3D web scene. We host the unified reality model in our GIS portal for our project to access and to see the site progress virtually on cloud. The 3D web scene enables us to fuse multi-type of information, such as street map, aerial photography, 3D model, and reality model into a unified 3D viewer. Our project manager, site manager, construction manager, and project planner are heavily using this viewer from site office and design office to understand the site context, review site progress, and inspect site incident. On this video, you will see all engineering design are from BIM model that are being published into 3D web scene viewer. The BIM models are the architecture models, structure models, and tunnel models. It is very detailed and it is very complex. Not just models. We also bring the attribute and classification from BIM model into this viewer. The attribute will help our project team to understand the full context of their reviews. Our journey is not ending here. We are continuously harnessing the power of ArcGIS technology for our corporate GIS application. We are currently developing comprehensive GIS database for our development and building control team, which will contain MRT SBK line information, engineering drawing, and electronic plans. We are also testing collector and survey 123 apps as our field mapping and data capturing tool for our engineers to monitor encroachment, zone violation, and illegal activities in MRT railway protection zone. We are also developing land management database using ArcGIS Online for our land management team to capture all land-related information, valuation, legal record, correspondence, and including financial data. And finally, we are looking at ArcGIS Analytics to help us to understand our feeder bus ridership patterns and trends, and later address our last mile connection issue. Now, we have come to the end of the presentation. I hope you have gained new knowledge on how MRT Corp has utilized digital engineering in the SSP Line project. Thank you for your attention, and I look forward to see you on board of MRT train soon.